Hello, my name is Anthony DeDios, and this is my project on applications of linear matrix algebra and Math 308B. For my first example, I did a how much food can be inside of a test tube for 3 bacteria strains. So for food A, we're given that the A can have 600, food B is equal to 600, and food C is equal to 600. In order to balance the bacteria and a limited amount of food consumption, we're able to get the following equations. So A is equal to x1 plus 2x2 is equal to 400. B is equal to 2x1 plus x2 plus x3 is equal to 600. And for C, we get x1 plus x2 plus 2x3 is equal to 600. So for solving number one, I took the data from the previous table and I put it in an augmented matrix. So as you can see, I began with R3 minus 2R2 and then continued to progressively reduce down. And then I ended up getting 3 pivot points, and then I had zeros on both sides of those. So I knew I was done, and I had a RREF. So my final values were x1 is equal to 160, x2 is equal to 120, and x3 is equal to 160. To conclude for that, the foods that the bacteria can eat in each test tube, we have that bacteria A can have 160, bacteria B can have 120, and bacteria C can have 160 in a test tube at one time in order to have equilibrium inside of the test tube for all the bacterias. So for my second example, I did a farming and manufacturing for the industries, and so a farm consumes half of the food and a third of the manufactured goods, and then manufacturing consumes half of the food and 2/3 of the manufacturing goods. So assuming the economy is closed and in equilibrium, we can find the relative outputs of farming and manufacturing industries. So pretty much from these givens, we'll get a table and we'll know that we have 1/2 and 1/3 for x1 and x2, and then we'll repeat the same process for the second row. And since it is a closed system, we know that it's set to equal 0. So after gathering that data from the table, we can see that we now have a augmented matrix, and we will be using our REF to reduce it down. And what I did was 2 operations at once. So I did row 2 minus row 1, and then I did R2 plus row 1 to simplify down to 1 and negative 2/3 on the top row, and then I have a free row on the bottom. So then I got that x1 had to be equal to 2/3 and of x2. So that the relationship to keep the community in balance would have to be 2 to 3. So we get that x1 is equal to 2 and x2 is equal to 3 in order to keep the goods inside the community balanced. To conclude, linear applications are used in a lot of things, and I actually found it really helpful that there is linear matrix algebra in circuits, since I'm interested in a lot of the engineering concepts, as well as like physics applications. And the one that I found most fascinating was how there can be a linear equation for services like painting and plumbing, and then being able to convert that into a augmented matrix, and then being able to keep it in a closed loop or a closed market, I guess, and seeing how that functions and is able to meet and give you a fixed amount of values for the services needed for each group that's inside of the system, which I thought was really interesting that that was able to be solved.